Good evening, everyone. This is Mr. Destiny. You're welcome to my YouTube channel once again. I'm going to be taking you through Waec chemistry practical. I saw some comments about the first video I released, and somebody was asking me some kind of question. The question was based on if you have the apparatus, is there any need to apply this method? Please, by any means, if you have the apparatus in your center and there's a way to conduct the experiment, and you believe the conduction of such experiments will give you a more accurate reading than the one I am giving, then by all means use your apparatus. These practical manipulations I do are for those people who are not opportune to have the necessary apparatus. There are some centers that they just give them hypothetical readings and all that. Some they collect readings from other centers which they are not sure of and give readings, and because of that, students get values that are not supposed to be. And it's not like they could do anything about it. They couldn't, because when you are not provided with the apparatus, you have little or no complaints to make. You just have to use their readings, and most of these readings are wrong. So that is why I am doing this, to give people ways to get accurate readings. I'm telling you, for years now, this has always been my culture. I do that for only my students. I only bring it out to the public because I know some people need it out there. So if you have a way to conduct the experiment and you are sure it will give you more accurate readings than the one I'm giving here, which I doubt anyway, because I'm sure of what I'm doing here. So if you are sure of what you have, then no problem, do it. Nobody is forcing your hands, okay? All right, so we are going to be considering Waec chemistry practical. The chemistry practical we are going to consider is titration, which is the practical that has the highest marks. The calculation, what do you expect? Okay, you can see the general overview about Waec chemistry practicals. Okay, I will just go through it and with a little explanation. Waec practical chemistry is divided into two parts generally. Okay, we have the quantitative analysis, and then we have the qualitative analysis. Okay, the quantitative analysis is also called titration, which is also called volumetric analysis. Okay, where you find the volume of a particular reactant that will be required to react with a fixed or known volume of the other reactants. Are you getting it? So we have the qualitative analysis, which will be the identification of ions. Okay, the quantitative analysis, like I said before, is also called volumetric analysis or titration. The quantitative analysis, okay, involves the use of a known, like I have explained it to you, involves the use of a known volume of a reactant. Okay, the known volume of a reactant. Okay, one reactant, we know the volume. Okay, then we want to determine the volume of the other reactant that will react with that particular volume of the reactants we know. Okay, you understand? Like in the one that will be coming out in this year Waec, we have the acid-base titration. Okay, where we use we get a known volume of the base. The reactant whose volume is known is the base. Okay, all right, and it's normally 25 centimeter cube. So we know the volume of a particular reactant. I guess it, and we want to get the volume of the other reactant to react with that volume of that reactant. Am I communicating? Like the one for acid-base titration is a titration between acid and base. That is the reaction between acid and base. The base, the volume of the base is always known, which is 25 centimeter cube, and then the titration will now be to determine the volume of acid that will react with that 25 centimeter cube of base. Okay, so in quantitative analysis or volumetric analysis, it involves the use of a known volume of a reactant, okay, to determine the volume of another reactant. Okay, all right, that would react with the known volume of what, of the first reactant, which is the base. Okay, all right, so the scope of this class is to analyze titration and how you are to expect questions to be set in this year's Waec practicals. Okay, we want to analyze titration. Okay, how do you expect it? Okay, as well as manipulations to get nice readings for your calculations. This is the titration overview. The kind of titration you are expected, like I told you, you are to expect in the 2021 Waec is the acid-base titration. That is what is coming out, okay, where an acid is reacted with a base. Okay, in this type of titration, an acid is titrated against a base. The goal is to determine, like I said before, is to determine the volume of the acid which is required to react with a known volume of the base. Okay, the volume of the base is 25 centimeter cube. I've already said that. Okay, the burette contains the acid, while the pipette is used to collect the 25 centimeter cube of the base into a separate container. Okay, so you use the pipette. The pipette is a kind of glass tube. Okay, all right, it is used to collect 25 centimeter cube of the base. We have two kinds of pipettes. We have the 20 centimeter cube pipettes and we have the 25 centimeter cube pipettes. The one that is recommended for Waec is 25 centimeter cube pipette. So when you collect it use it like is a kind of elongated, and it is straw-like. So you use it to suck the base, okay, to a particular level. When it gets to that max level, the level is marked on towards the top of the pipette. Okay, when it gets to that level, you stop pipetting. Okay, you take it. The volume of base that will be inside that pipette will be 25 centimeter cube. Okay, so you put it in a separate container, and then you pour an indicator. The function of that indicator is to determine when the acid that you will be pouring into the base have completely reacted to the base, because that is our aim, to determine where, at what point in time, the reaction gets completed. Okay, so the indicator is colored. Okay, all right, so it will give the base a particular kind of color. That's when you start pouring the acid, at the point where all the acid that you have poured into the container have reacted completely. It's the indicator will change color. Okay, that is to determine, that is to note when the reaction has been completed. Okay, and that is a function of the you can see the apparatus that is expected to be used. Okay, you see towards the left hand side, you see a titration setup. Okay, so that's purple colored that purple color liquid chemical inside that container is the base. Okay, an indicator have been poured. Okay, so the base is normally colorless. Okay, but when you pour an indicator, it becomes colored. All right, and you see that the burette, they labeled it the burette. Okay, it contains the acid. Okay, the acid will be poured into the base. Okay, okay, so that is what happens. The standard solution is the acid that is inside the burette. Okay, so the retort stand is holding the burette in position to make it stand. Okay, that is the function of the retort stand. An apparatus that cannot stand on its own, it is used to put it in position. Okay, then if you move up a little, if you move up to the other apparatus, you see the pipette. Okay, okay, the volumetric pipette, it is labeled there. You will see it very, very well. And then the other one towards the right, you see every other apparatus, the burette and everything, labeled, the measuring cylinder and everything. They will be used for transferring liquids from one container to another container for the purpose of the titration. Still on the titration overview, the acid will then be poured. Okay, the acid will be poured from the burette into the container containing the base. Okay, so we as you the essence of explaining all this is for you to know what you are supposed to do, because you wouldn't know how to manipulate when you don't know what to do. Okay, so that is the essence of all these explanation I'm giving you first, so that you know what you have to do. For those of you who don't know, and for those of you who know, for you to ascertain what you have to do. Okay, the acid will be poured from the burette into what? The container containing the base. Okay, that container you have put the indicator, which colors the indicator. You now start pouring the acid from the burette. The burette has a kind of tap, a kind of for some burettes is a tap like this thing that you can open to pour the acid into the base, or for some it's like a ball. If you press the ball, the thing opens, okay, and the acid inside pours into the base. Okay, that is what we call titrating. Okay, this is called titrating. All right, now the student continues titrating until there is an indicated color change, like I told you. Okay, all right, the color will change to show that the acid that has been poured into the base has reacted completely with the 25 centimeter cube of the base. Okay, all right, this is called the end point. Are you getting it? Now the level of the acid in the burette before titration, okay, started before the level of the acid in the burette before the titration started is known as the initial reading. Okay, so before you started the titration, there is a level where it is normally you fill the burette with the acid and adjust the level to be at the 0 centimeter mark. Are you getting it? So the initial reading will be the level, the reading just before you started your titration. Okay, as you now started titrating, as at when the color changes, that is the end point. Okay, that is the final reading. Are you getting it? So the level of the acid in the burette before titration started is known as the initial reading. The level of the acid after there is a color change is called the final reading. Okay, now the difference between these two readings, the initial and the final reading, that is what gives the volume of the acid, okay, used. That is the acid that has reacted with the 25 centimeter cube of the base. I hope I am communicating. If I am too fast, you can rewind, you can pause, rewind and play it again so that you get it full what we are talking about. Okay, the acid is labeled A, okay, while the base is labeled B. According to this here Waec, the acid will be labeled A and the base will be labeled B. Still on the titration overview, what you have to know about titration. The first titration is called the rough titer. The rough titer, will tell me the rough titer because you don't really know the volume of the acid that will react with that 25 centimeter cube of base. So there's a tendency to always continue to be pouring it carelessly without actually getting it. Okay, so as you are pouring and you're pouring, once the color changes, there's a tendency, because you don't know that will be the points where the color changes, so there's a tendency to have poured more acid into the container even after the color changes. Okay, that's why we call it rough titer, because it is rough, it is not accurate enough. Okay, all right, the experiment, you are going to repeat it severally. Say the experiment is repeated severally to obtain consistent titer value. Are you getting it? You repeat it again. That will now be your first titer. So when you are approaching the end point, you know the range where it will be. So you are becoming more careful and be putting the liquid drop by drop, so that immediately the color changes, you stop. Are you getting it? Okay, you do that. That one will be more accurate than the first, but not accurate enough. Okay, you do that repeatedly. First, second. That's why we have the first titer, the second titer, the third titer in the table. I will show you the table so that you know what we are talking about. Okay, we have the first titer, we have the second titer, and then we have the third titer respectively, in addition to the rough titer. Okay, each titer column has volume of A used, okay, which will be the final reading minus the initial reading. Okay, the average Titer reading is the average volume of A used. Okay, all right. So you have gotten the volume of A used in each Titer. Okay, then the average Titer reading will now be what? Your first Titer plus your second Titer plus your third Titer all over 3. You can also make it to be 2. So now be first Titer second plus second Titer all over what? All over 3. All right. Now this is how your table should look like. Okay, your initial reading is 0.00, of course. Then you start titrating. As you're titrating, okay, the final reading for this experiment, for the experiment that gave this table, is 24.40. Okay, so 24.40 minus 0.00, okay, will give us what? 24.40. Okay, that is the volume of A used. Okay, now the first Titer, you can see that the first Titer was more accurate than the second Titer. Okay, the first Titer was the end point, which is the final reading, was less compared to the rough Titer. That is to show that during the rough Titer, more volume was added because we didn't know that is the region. 24.35, 24.40 is the region where the color will change. So you can see that in the first Titer, the final reading was more accurate. Okay, so in the first Titer, to get the first Titer, you have to refill it again to start from 0.00. Okay, now for the second Titer, you can see that our initial reading for the second Titer is the same thing as the final reading for the first Titer. The reason being that the volume of the total volume of the burette is 25 centimeter cube. Okay, so if your end point for your first Titer is maybe 26, okay, you will expect for the second titration, because to get the second titration, you have to throw away the used base. Okay, the one that the color have changed, you throw it away, rinse it, and then pipette another base, put it in the container, and put another indicator. Okay, so since it is the same base, okay, you expect the same volume of acid that will react with it to neutralize it. Okay, so the color will change almost at the same volume. Okay, so you're expecting something like 26, towards the range of 26 centimeter cube to neutralize the base again. Okay, so if it is 26 that you stop for your initial and you want to continue from there means you don't refill the acid. You don't refill the acid. You just replace the base and then you continue titrating from there. That means your initial reading will now be 26.00 centimeter cube. Okay, and if you continue titrating from there, you will find out that it will get to maybe 52 point something, okay, before the color will change. Okay, by then the acid in the container would have been exhausted. Okay, it would have been exhausted before the color will even think of changing again. Okay, do you understand? Because the total volume for the burette is 50 centimeter cube. So because of that, when it is less than 25, it is advisable to continue from there. Okay, because before it will change again, it will be 40 something. Okay, if it's less than maybe like this case now, it's 24.30. Okay, before it will change again, it will still be 40 something. So that is feasible. So you can continue from there, like we did in this place. We continue from there. We just replace the base, put the indicator, and then continue from there. So when we did that, we found out that it was 48.70 that the color changed. Okay, so that was our endpoint for our second Titer. Then we did volume of A used for the second Titer to be 48.70 minus 24.35. Okay, that gives us 24.35. Now we see that the end point, that is the final reading for this second Titer, is 48.70. Okay, so if you observe, you will see that we refilled the acid again to 0.00 and take our initial reading to be 0.00. Okay, while our final reading is 24.35 again. Okay, when you do that minus 24, it will give you 24.35. Do you get it? So the rule is that no two in the volume of A used, okay, no two volume of A used should be more than a difference of 0.20. In other words, what am I trying to say? That if your the volume of A used, any two reading is is the difference is more than 0.2, it means your reading is not accurate. For example, the volume of my A used in the first Titer is 24.35. The volume of my A used in the second Titer is 24.35. Okay, the difference is 0.00, which is acceptable. Okay, all of them, it is acceptable that all of them will have the same Titer readings. Okay, do you get it? And that is to show that your experiment is more accurate. Not that you have 24.35 in the first Titer, and the second Titer you're having maybe 23.50. Okay, that is more than you're having maybe 20, yeah, you're having 23 points or 22 points. Okay, that the difference is more than 0.2 centimeter cube, which shows a less accurate result. And now we get back to the business of the day, the manipulation. Okay, this manipulation is to give you an accurate value, because most times we find out that when we conduct the experiments, we get values that are far from each other and are less accurate. So that's why I'm here to teach you how to manipulate the values, okay, to get a reading that is very, very accurate. Okay, now it is advisable to manipulate the values due to a number of reasons. Okay, what are those number of reasons? Waec judges your experimental results based on how accurate they are. Okay, the less the accuracy, the less the mark. Are you getting it? So they compare these values with the ones to be provided by the chemistry teacher in the report booklet after the practical examination. Now, I have been working with Waec, with different centers. Okay, that has to do with Waec for years, and there is a report booklet, Waec report booklet, that the chemistry teacher that conducted the titration, okay, before the examination, okay, must fill. Okay, the teacher actually fills the end point, that is the average Titer value for the whole experiment in that report booklet. He fixed the first Titer, second Titer, and third Titer, and then the average. Now that is what they're going to use to mark everybody's results as far as that center is concerned. The reason being that the reason why the endpoint for different centers would vary, which was why Waec brought out this system, is because different we don't know the kind of chemicals used to prepare it. Okay, we have different chemicals that are being used to prepare. Like for example, what I'm trying to say is that different chemicals can have different amount of impurities in them. Okay, where even if they say we should use distilled water, okay, this distilled water vary in your impurities. Okay, the impurity level can affect results in different centers. Okay, so there's no way you can ascertain that this value is the actual value for as far as all the centers is concerned. Do you understand? And the side reactions too, there are side reactions in every chemical process. So this can affect the readings, okay? So that is why Waec places different places that rule that the chemistry that use the acid and base that is used in that center, okay, the teacher is to provide a report, okay, of the end point. Do you understand? So since you use the same acid as the teacher, okay, in question, all right, you are supposed to have the same end point. So that's why they will use that teacher's value to mark everybody's own. And funny enough, they do set some calculation question which you will use that particular endpoint to solve. So if you fail the endpoint, you have failed everything, okay? Because everything that you are going to solve under that titration will be based on that endpoint. Okay, so once you fail the endpoint, it doesn't matter whether you know the calculations and everything, you fail the rest. And that is why you should be on the lookout, if possible, if you have access to your chemistry teacher or to the chemistry teacher that will be taking that will be filling the report booklet, okay, before that day, you ask him or her, what endpoints are you using? Okay, so when they supply it to you, you use that what endpoint to form your table. I will teach you how to use the endpoint to form your table so that when you solve for your first Titer, second Titer plus third Titer all over 3, you will get that particular endpoint given to you by the teacher. Okay, it is this value they use to mark every student's script. Thus, no matter what you do, your experimental results must tally with the ones provided by your teacher in the. Now, students are therefore required to ask their chemistry teachers, like I said before, the value of the endpoints that he or she intends to impute in the report booklet. Okay, they are then required to construct their tables to agree with these values. Okay, now the difference between any two of the values of A used, the difference between, I told you before, I've given you this rule, the difference between any two of the values of A used must not be greater than 0.20 centimeter cube. Also, the endpoint provided by your teacher should not be above 0.20 centimeter cube different from yours. Okay, they should either be the same, or if you calculate the difference between the endpoint provided by your teacher and your own, it should not be more than 0.20 centimeter cube. But to be on the safe side, I advise it should be the same. Okay, there's no penalty whatsoever. Okay, for that. So this is the standard. Of course, this is the Waec standard. Okay, I shall teach you how to construct the table given the endpoint. All right. Now let us assume that we were given the endpoint 24.70 centimeter cube to solve. Okay, now since the first Titer is rough, we shall take a value slightly higher than 24.70 centimeter cube. Okay, say 24.80 centimeter cube. Okay, the initial reading should be 0.00 centimeter cube. Of course, you should know that. So this is your table, your rough Titer. Okay, then the initial reading in centimeter cube is 0.00, and then the but before then, you have to, before you put anything, the first thing you are going to put is the volume of A used, because that is where you are trying to arrive at. Okay, so the volume of A used, I said initially, it was what, 24.80 centimeter cube. So you fill it first. Okay, then put your initial reading point as 0.00. Then you look at what value will you put in the final reading, so that the final reading minus the initial reading will give you that volume of A used that you have put. Okay, you'll see that it is easily done. It will be 24.80. So you put your 24.80 in the final reading, so that when you minus both of them, it will give you 24.80. Do not forget that we are trying to arrive at an initial at an endpoint or average Titer value of 24.70. Okay. Now, in the first Titer, we ought to be more careful. Okay, yeah, it's normal. You become more careful in the first Titer. So we use a more accurate value. Let's say 24.70 centimeter cube. Okay, so you put the one that actually you are solving towards, because this is the first Titer. No joke. Okay, so you first of all feel, like I said before, you first of all feel the volume of A used, then put the initial reading. Okay, you know you are refilling the acid, so your initial reading is 0.00. okay, so you put a value in the final reading. Okay, that's when you say the initial reading minus final reading to give you the volume of A used. So in this first Titer we put 24.70, because 24.70 minus 0.00 gives us 24.70. Okay, that's for our first Titer. Now, since the level of the liquid at this point is still less than, this is what I just explained. I explained to you before about more than 25, taking your initial reading as the final reading for your initial one. So there's there's nothing here that is new to you. Since the level of the liquid at this point is still less than 25 centimeter cube, we do not need to refill the acid in the burette to 0.00 centimeter cube again. Okay, we take this level as the initial reading for the next Titer. Okay. The only thing that needs to be replaced and new is the indicator and the base. Okay, we fill the volume of A used for the second Titer. Okay, first. Okay, since we are trying to obtain a value close to or equal to 24.70 centimeter cube, so you fill the average volume, the volume of A used first. Okay, then you put your initial reading will be your final reading for your first Titer, of course, which is 24.70. So you're now going to look for what value of what value will you put in the final reading? Okay, that's the final reading minus the initial reading will give us 24.70. Okay, think about it, and then you move to the next. You see the next slide, and then you know that you are correct. Okay, it will be I think 49.20 I get. Okay, so that will be the volume of A. That will be the final reading for the second Titer. Now you can see that in the table that it is 49. Okay, I said 49.2. It's actually 49.40. Okay, so that 49.40 minus 24.70 gives us 24.70. Okay, all right. Then of course you are going to refill the acid. Okay, do you understand? You refill the acid again and start from 0.00, because now the final reading has crossed 25 centimeter cube. Okay, the final reading that should be placed in the table to make the difference between the final and initial reading equal to 24.70 centimeter cube is 49.40 centimeter cube. Okay, if you look at it, it's correct. Okay, the burette is then refilled since the level has gone below the level have gone below the 25 centimeter mark. Okay, so we have the initial reading becomes 0.00 centimeter cube. If we must get 24.40 centimeter cube as our volume of A used, our initial reading for the final Titer, which is the third Titer, I getting it, should be you know that now it should be 27.40 centimeter cube. Okay, all right, that will now give us our final table. Now this is the final table. Okay, all right, 27.40 minus 0 for the third Titer. Okay, we have 27.40 minus 0 will give us what? 27.40. So by doing if you label your table like this, okay, all right, you will find out that your first Titer plus your second Titer plus your third Titer divided by 3 will give us what? Your volume of A used. Okay, all right. Now, in every titration practical, we are required to get the average Titer value, which is the average volume of A used. Okay, so average Titer value or reading will be first Titer plus second Titer plus third Titer. Like I told you, you could make your own 2. Okay, it will still be the same. So you can be first Titer plus second Titer all over 2. Okay, as reflected from your table. And then when you do this for this one, it will give us 74.10. Okay, so divided by 3 will give us what? 24.70. all right, centimeter cube. Okay, now do your own, obtain the table for the endpoint, 22.70 centimeter cube. Okay, and let's see what you have. Give me if you can screenshot it and send it in the comment section. All right, or you send it to my WhatsApp. Okay, in my previous video I gave there's a place my number is. Okay, you can send it to my WhatsApp, or let me check the validation. All right, thank you very much. Now, like I told you before, there's always a calculation under it which you will use your endpoints to solve. Okay, students are required to solve some calculations. Okay, some calculation questions after constructing their respective tables. Okay, after you construct your tables, you have to solve some questions. Okay, the calculations are mainly based on the concentration of either the acid or the base or both. Okay, they will ask you on concentration. Okay, now what's concentration? Concentration has to do with the kind of the amount of solutes present in a solution. Okay, you know what we call solute and solvent, right? And solution. Okay, the solute is a solid substance, mostly solid. Okay, that are required to dissolve in the liquid. The liquid is called the solvent. While the mixture after the solute have dissolved, we call it what? A solution. Okay, so the amount of solutes present in that solution, okay, the amount of that salt that you dissolve in that solvent, okay, present in that solution is what we call the concentration. Okay, I always try to use the population of solutes present in the solution. Okay, for a better understanding. So basically there are two types of concentrations. Okay, these are the mass concentration and the molar concentration. However, the name they call them in Waec is not mass concentration and molar concentration. Okay, so you don't use this term to describe it. Okay, in the next couple of slides I'm going to tell you how they used to what Waec recommend that is being called. All right, now generally the concentration of a solution is defined as the amount of solute present in the solution. Okay, I like to use the word population, like I said, or solutes present in the what. Still on the calculation, okay, if the amount of solute in terms of mass is in terms of mass, okay, all right. So I told you we have two types of concentration: the mass concentration and the molar concentration. So if we are using the kind of concentration, okay, depends on what physical quantity you are using to quantify the solutes, okay, to show the solutes present in that what, in that solution. Do you get it? So if we're using mass to quantify the amount of solute that was dissolved in that solvent, okay, the kind of concentration we're talking about is the mass concentration. But if we use number of moles instead, okay, we are talking about what? We are talking about molar concentration. Okay, all right. So the mass concentration is referred to as the concentration in gram per dm cube. Mostly written as that, okay, gram per dm cube or gram per dm cube. Okay, anyone you write, you get the same thing. Okay, similarly, if the amount of solute is in terms of number of moles, like I told you, okay, in moles, okay, then we are talking about molar concentration. Okay, all right. In Waec, the molar concentration, I told you that they don't have they don't normally refer them as molar concentration or mass concentration. Okay, in Waec, the molar concentration is concentration in mole per dm cube. Okay, they call molar concentration in Waec as, they refer to it as concentration in mole per dm cube. Okay, mostly written as mole per dm cube or mole, yeah, okay, but for mass concentration, okay, we refer to it as what, concentration in gram per dm cube. Okay, that is the standard. So you don't call it mass concentration, you call it concentration in gram per dm cube. Okay, you don't call it molar concentration, you call it what, concentration in mole per dm. Now let us assume that 600 centimeter cube of water was poured in a container of 50 gram. Okay, let us assume that 600 centimeter cube of water was poured in a container and 50 gram of sodium chloride, NaCl, your normal salt, was dissolved in the water. Okay, now you pour 600 centimeter cube of water, okay, in a container, maybe a beaker or maybe a basin, okay, and then you add about 50 gram of sodium chloride. Okay, we can say the concentration of the solution is 50 gram of sodium chloride per 600 centimeter cube of solution. That is because you dissolve 50 gram of sodium chloride in 600 centimeter cube of the solution. Okay, of course, that was what you did. So 50 gram is present in what, 600 centimeter cube of solution. Note that this is not the standard, okay, because we normally use gram per dm cube. Okay, now that gram per dm cube means the amount in grams of what, of the solutes present in 1 dm cube of the solution. Dm cube is a unit for measuring volume. So if you dissolve that 50 gram of sodium chloride in 600 centimeter cube of solution and you turn it, you stir it very, very well, all the 50 gram, okay, would have dissolved in the what, 600 centimeter cube. Okay, do you understand? So it would have been spread evenly to all parts of the solution. Now you now collect only 1 dm cube of the solution. What mass of sodium chloride will you find there? That is the meaning of mass concentration. Okay, the mass, okay, in grams of the solute present in 1 dm cube, just 1 dm cube of the solution. Okay, all right, so the concentration must be in gram per dm cube. Okay, take note that the unit of volume as recognized by Waec chemistry is dm cube. So we convert that 600 centimeter cube to what, to dm cube, by dividing it by 1000. Okay, when we do that, we'll get 0.60 centimeter cube. Okay, we therefore have 50 gram of NaCl, okay, dissolved and evenly distributed across the whole 0.60 dm cube of water. Okay, all right. Now the mass concentration is, however, the amount, okay, in grams of solid present in 1 dm cube of the solution, right? If 50 grams of NaCl is present in 0.60 dm cube, right? Now you are now looking for the mass that will be present in 1 dm cube. You can write in your rough book, you write 50 gram write an arrow 0.60 dm cube, then go to the next line, write x, okay, arrow, okay, 1 dm cube. Do you understand? So if you cross multiply, you get the value of x. Okay, the value of x is the volume, that is the amount of solid present in 1 dm cube. Or you can just go straight and write what? The mass divided by the what? By the volume. The mass of the solids divided by the volume of the solution. That should give us what? The amount in gram present in 1 dm cube. That is 50 gram divided by 0.60 dm cube. Okay, that will give us our 83.33 gram per dm cube. That means if we check 1 dm cube of the solution, we will find 83.33 gram of what? Of sodium chloride in that 1 dm cube, just that 1 dm cube of the solution. Do you understand? That is what it means. Okay, now if the solution contains 88 gram of solute, that is NaCl, in 750 centimeter cube of solution, then find the concentration in gram per dm cube. That is, find the what? The mass. Okay, all right, find the mass that will be present in mass in gram. Okay, that will be present in what? In 1 dm cube of the solution, using the same method. Okay, as an exercise for review. Okay, when you get that, you tell me using the comment section. Now, the molar concentration is similar to mass concentration, okay, except that it has to do with the use of number of moles of the solute instead of amounts in grams. Okay, we use number of moles to quantify it. Okay, we can convert mass to number of moles, okay, by dividing the mass by the molar mass of the what? Of the solute. Do you understand? Okay, all right. The number of moles of solute present in 1 dm cube of the solution. That if you collect 1 dm cube of the solution, what will be the number of moles, okay, of that solution, of that solute that will present in that 1 dm cube of the solution? If, for example, a statement reads the concentration of a solution is 0.05 mole per dm cube, okay, that means that it simply means that 1 dm cube of the solution contains 0.05 moles of the solute. Okay, this means that 9.34 dm cube of the solution will contain, of course, if 1 dm cube contains 0.05 moles, definitely 9.34 dm cube will contain what? 9.34 times 0.05 moles of the solution of the solute. Do you get it? Now we get down to what calculations you have to expect. Okay, now to solve questions in Waec chemistry practicals, there are 2 relationships we use. Okay, all right, these are CAVA all over CBVB equal to NA over NB. Okay, and then we have concentration of A in mole per dm cube equal to concentration of A in gram per dm cube all over molar mass of A. Or we use concentration of B in mole per dm cube equal to concentration of B in gram per dm cube all over molar mass of B. These two, concentration of A in mole per dm cube equals to concentration of A in gram per dm cube all over molar mass of A, and concentration of B in mole per, they're actually one relationship. Okay, do you understand? They're actually one relationship. That is, concentration of a particular solution in mole per dm cube will be equal to concentration of that same solution in gram per dm cube all over molar mass of that same solution. The concentration of in mole per dm cube of that solution is molar concentration. So we can convert this to molar concentration is equal to what? Mass concentration all over molar mass. Okay, do you understand? So if you are using concentration of A in mole per dm cube, then it has to be equal to what? Concentration of A in gram per dm all over molar mass of the same A. Or if you are applying it to B, to be concentration of B in mole per dm cube all over concentration of B in gram per dm cube all over molar mass of B. For the first relationship, which is CAVA all over CBVB equal to NA over NB, okay? CA is the concentration of A in mole per dm cube, okay? Like I told you, okay? CB is the concentration of B in mole per dm cube, okay? All right, we are defining the terms in the first relationship now, okay? VA is the volume of A used, okay? Which is your average Titer value, the one you solved for in that your table, remember? Okay, so which is the average Titer value? Okay, every Titer reading you got from your experiments. Okay, VB is the volume of B, which is your pipette reading. Okay, the volume of B is, you know now, to be what? 25 centimeter cube. Now, if you go to the other part, okay, I know you must have written the 2 relationships down. Okay, if you have your book, okay, and your pen. Okay, if you go to the other side of the equation of the first relationship, you find out that we have NA over NB. Okay, Na is the number of moles of acid, okay? All right, the number standing with the acid in your equation of reaction, because they always give you equation of reaction. Okay, so in your equation of reaction, okay, you just look at the number standing with the acid in the equation of reaction. Okay, that will be your Na. While Nb is what? Is the number of moles of the base, okay? All right, that is a number standing with the base in the equation of reaction. Okay, for this for the second relationship, okay, the concentration of A or B in mole per dm cube and gram per dm cube are familiar to us. I've explained it before. So the molar mass of A or B is calculated by adding the relative atomic masses of each of the elements present in A or B. Okay, let me further explain that relative atomic mass. Let us try to calculate the relative atomic mass of B. Okay, for this Waec, B is sodium hydroxide. Okay, so you want to calculate the relative atomic mass of sodium hydroxide. You add the relative atomic masses of sodium, oxygen, and hydrogen, which makes up the chemical formula of sodium hydroxide. Okay, you'll be given the relative atomic mass. Don't worry, you'll be given the relative atomic masses of each of them in brackets. Okay, so you will see that Na will be 23, O will be 16, and H will be 1. So when you add all of them together, it will give you 23 plus 16 plus 1, which will give us 40 gram per mole. Okay, that is the relative atomic mass. I mean, that's the molar mass of what? Of B. Okay, when you want to apply it now, you now say concentration of A in mole per dm cube, I mean concentration of B in mole per dm cube, all over concentration equal to concentration of B in gram per dm cube all over molar mass of what? Of B. Okay, that will now give you, that molar mass of B will now be 40 gram per mole. Now we are looking at the first relationship, which is CaVa all over CbVb is equal to Na. Okay, so Va is obtained from the experiment, of course, your endpoint, your average Titer value. Okay, Vb is obtained from the experiments as well. Okay, which is your 25 centimeter cube, okay, of base. Okay, all right. Now Na is number of moles of acid obtained, okay, from the equation of reaction, the number standing with the what? With the acid. Okay, all right. In this experiment, the number standing with the acid, you find no number there. That means the number there is 1. You know, in chemistry, 1 is always invisible. Okay, all right. You find 1 also in the number in the base too. Do you get it? It's standing with it. Do you understand? It's not indicated there, but it is what is standing there. So in our experiment, Na is 1. Okay, in this our experiment, Nb is what? Is 1. Okay, now if you look at that relationship, CaVa all over CbVb is equal to Na over Nb. 4 of them is already known from the experiment and the equation. That's why I said the only factor that determines whether this first relationship is used or not is the availability of Ca of Cb. Okay, Ca or Cb. Va is known, Vb is known, Na is known, Nb is known. So whether we use this relationship or not, we determine, we depend on whether we have Ca. Then we can, if you have Ca, we can use Ca to find Cb. Okay, Ca might be given in the question. They will say A is a solution of hydrochloric acid. Okay, or they will say A is a 0.01 mole per dm cube hydrochloric acid. Okay, so when you see A is blah 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 mole per dm cube, you know that is molar concentration of A, which is Ca. So then you now use that one to calculate what? Cb using this formula. Do you understand? Okay, so if either Ca or Cb is available, we can then use this relationship to find the other. If Ca is present from the question, we use the relationship to find Cb, and vice versa. That is, if Cb is present for the question, okay, we can use that relationship to find what? Now, if the both of them, that is your concentration of A in mole per dm cube and your concentration of B in mole per dm cube, they are not given, and then it is either they gave the mass concentration of A or they gave the mass concentration of B. Okay, so if they, most likely they will not give you Ca and Cb. Okay, so you have to calculate Ca and Cb. Okay, all right. Now, if they don't give Ca and Cb, okay, they would have given either the concentration of A in gram per dm cube, that is the mass concentration of A, or they gave the mass concentration of B. Do you understand? So if you are given the mass concentration of A, you use the other relationship, okay, to find the concentration of that same A in mole per dm cube. Do you understand? Okay, we know that concentration of A in mole per dm cube equals to concentration of A in gram per dm cube all over molar mass of A. So if they gave you the concentration of A in mole per dm cube, all you just have to do is find the molar mass of A, then divide the concentration of A in mole per dm cube by the molar mass of A. That will give you the concentration of A in mole per dm cube. Do you understand? Do you get it? That is, you divide the concentration of A in gram per dm cube by the molar mass of A. Okay, you get the concentration of A in mole per dm cube. Then you are now going to use that Ca you just got now, put it in CAVA all over CBVB is equal to Na over Nb, okay, to get your CB, concentration of B in mole per dm cube. Then most likely they will now ask you calculate the concentration of B in gram per dm cube. Okay, so having gotten CB from CAVA all over CBVB equal to Na over Nb, okay, you can use that to get your concentration of B now in gram per dm cube by using that same relationship. Concentration of B in mole per dm cube equals to concentration of B in gram per dm cube all over molar mass of B. Okay, then you cross multiply. Okay, so your concentration of B in gram per dm cube will now be equal to what? Concentration of B in mole per dm cube times molar mass of B. Do you understand? So if they gave us the mass concentration of A, we can use the second relationship, okay, to find the molar concentration of A, since we can calculate the molar mass of A. Okay, so we can calculate the molar mass. We'll do an example so you understand, you have a better understanding. Okay, all right, so you find the molar mass of what? You find the molar mass of A, then divide the concentration of that concentration of A in gram per dm cube that they gave, divided by what? By the molar mass of A. Okay, you get the concentration of A in mole per dm cube. Then use that one. Okay, okay, do you understand? We can then use this Ca to get Cb using the first relationship. On the other hand, if what was given in the question is mass concentration of B, that is concentration of B in gram per dm cube, simple, the same way, we use the second relationship to get Cb. We then use this value to get Ca using the second relationship. I think using the first relationship, okay? All right, and that is that. Using the second relationship, yeah. That is using concentration of B in mole per dm cube because the concentration of B in gram per dm cube all over molar mass. The same thing I explained before. Okay. Now we are faced with one example, an exemplary demonstration. Okay, this is the way you are expecting it to come. Okay, this is how it is. It will be similar to this kind. I've already explained how you do it. Okay, now we are faced with what? With an exemplary demonstration. 1. A is a solution of dilute HCl. B is a solution containing 45 grams of sodium hydroxide per 900 centimeter cube of solution. Of course, you know that is your concentration of B in gram per dm cube, but it is not yet in the standard form. So you have to convert it to the standard form first. But before then, put A in the burette and titrate against what? 25 centimeter cube portions of B. Okay? Titrate. Repeat the experiment to obtain consistent Titer readings. Calculate the average volume of A used. Of course, you know how to do that now. We've done that before. From your results and information provided, determine the concentration of A in mole per dm cube. Of course, the concentration of B in mole per dm cube. Okay? And then the concentration of A in gram per dm cube. This is how you are going to expect it. Okay? Now we move on to the solution, to the answer. How will the answer look like? Now if you look at the answer, you have what? 40 grams of B is present in 900 centimeter cube of solution. 40 grams, that means they dissolve 40 grams of B in 900 centimeter cube of solution. Okay, that means 40 grams. We have to convert that 900 centimeter cube to dm cube. Okay, that means 40 grams is present in 900 over 1000 dm cube of solution. Thus, concentration of B in gram per dm cube will now be what? 40 divided by 0.9, okay, because the value of the volume of the solution is, when converted, is 0.90 dm cube. Am I communicating? Okay, so that is that. So that will give you 44.44 gram per dm cube. You know what that means, right? That is, if you take just 1 dm cube of the solution, you will find 44.44 gram of what? Of the solute, that is of sodium hydroxide. Do you understand? Then we have the molar mass of HCl, of course, will be what? 1 plus 35.5. They will give you in the brackets, they will tell you H is equal to 1, Cl equal to 35.5. So if they don't give you, they will tell you HCl equal to 36.5. That means they've already calculated it. Okay, so it will be 1 plus 35.5 equal to 36.5 gram per mole. Okay, then molar mass of B, all these things you calculate them, you write them down first, so that when you are solving, it doesn't give you problem. So molar mass of B, okay, which is sodium hydroxide, is 23.16 plus 23 plus 16 plus 1 equal to 40 gram per mole. So of course, you know that Na is equal to 1 and Nb equal to 1. To get concentration of A in mole per dm cube, we must find the concentration of B in gram per dm cube, because we have to get the concentration of A in mole per dm cube. But we must first calculate the concentration of B in gram per dm cube. Okay? Okay? We have to get we have to find the concentration of B in gram per dm cube, since we have the concentration of B in gram per dm cube. Sorry, we have to find the concentration of B in mole per dm cube, okay? Since we have the concentration of B in gram per dm cube. Okay? Do you understand? So we can calculate the concentration of B in mole per dm cube using that concentration of B in mole per dm cube equal to concentration of B in gram per dm cube all over molar mass of B. Do you understand? Okay, we can use that to get the concentration of B in mole per dm cube. Then use that concentration of B in mole per dm cube, like the Ca, to find, Cb, to find Ca using CaVa all over Cb, Vb is equal to Na over Nb. This is the pattern the question. Now we gone. Okay, concentration of B in mole per dm cube. Okay, Cb will be equal to concentration of B in gram per dm cube, like I said before, all over molar mass of what? B. So our Cb will now be, you will know that concentration of B in gram per dm is 44.44. So 44.44 all over the molar mass of B, which is 40. Okay, all right. So we will do that, and then we'll get 1.11 mole per dm cube. Do you understand? So concentration of B in mole per dm cube is now 1.11 mole per dm cube. All right. Now we can now use that Cb now, put it in CaVa all over Cb Vb to get our what? To get our Ca now. How are you getting it? So CaVa all over Cb Vb is equal to Na over Nb. Then we'll substitute all the values. Okay, we know what Va is, which is our endpoint. Vb is our 25 centimeter cube. Na is 1. Nb is 1. Okay, we then substitute all the values there, since we now know Cb. Okay, we get what? Our Ca. Do you get it? Now we see that we use CaVa now. Ca times, and the endpoint is 24.70 all over 1.11 times 25, which is equal to 1 over 1. Okay. Then if you cross multiply, you have Ca times 24.70 times 1 equal to 1.11 times 25 times 1. Okay, if you divide both sides by 24.70 times 1, okay, you get Ca to be 1.12 mole per dm cube. Okay, now from the relationship, concentration of A in mole per dm cube is equal to concentration of A in gram per dm all over molar mass of A. Now we can now use this concentration of A in mole per dm cube now to find the concentration of A in gram per dm cube. Okay, all right. So concentration of A in mole per dm cube all over equal to concentration of A in gram per dm all over molar mass of A. So you cross multiply, you have concentration of A in gram per dm cube is equal to what? Molar mass of A times concentration of A in mole per dm cube. That's what we have there, and then we have, that is 36.5 times 1.12. That will give us 40.88 gram per dm cube. I hope you are with your book and you are calculating with me. Okay, That is only when you can, everything will make sense. You cannot just hypothetically be using your brain. Even if your brain is sharp, you should still hold a book to write and then calculate this along with me. All right. Now we see another exemplary demonstration 2. Okay, A is a solution containing 87 grams per 500 centimeter cube of impure HCl. Impure. That means in this A now we have impurity. It is not just HCl that is inside. We have other substance. Okay, as far as a substance is concerned, any other substance that is inside there is an impurity. In water, if water is inside something and then you have some other substance like sodium, okay, sodium becomes an impurity. Okay, do you understand? So which means in this 85 grams per 500 centimeter cube, okay, this 85 grams in short, you will find out that what made this 85 grams, this 87 grams per 500 centimeter cube up to this 87 grams is the presence of impurities. Okay, if not, the pure A, which is the one that is HCl in that component, in that solution, okay, will not be up to 87 grams. Do you get it? So B is a solution containing 56 grams per 400 centimeter of sodium hydroxide solution. So this one is pure. Are you getting it? Take note that when you are solving, your A, it is the one that is pure. It's a pure substance that will react. Like this is 7 grams. We know we have pure substance and we have pure A and impure A. Okay, that makes up this 87 grams. It is that pure A that will react with B, and it is that pure A that all these formulas CAV and will work for. Do you understand? All the substance will not react. Only HCl will react. And so only the amount that reacts will not be true for the calculations. Do you understand? So then I say put A in the burette and titrate against 25 centimeter cube portions of B. Okay. Repeat the experiment to obtain consistent Titer values. Calculate the average volume of A used. From your results and information provided, determine the concentration of B in mole per dm cube. First, concentration of A in mole per dm cube. Concentration of pure A that took part in the reaction, okay, in gram per dm cube. Do you understand? Then we now find the percentage pure. Now, first of all, we change the volumes, okay, from centimeter cube to dm cube. You know that one. 500 centimeter cube divided by 1000 gives us dm cube, and 400 centimeter cube divided by 1000 gives us 0.4 dm cube. Now, concentration of A, impure A in gram per dm cube will be 87 gram divided by 0.5. That gives us 174 gram per dm cube. Now, concentration of B in gram per dm cube is 56 gram divided by 0.4 dm cube. Okay, all right. That will give us 140 gram per dm cube. You know now it will be the mass of the solute all over volume of solution. That's how to get concentration of whatever in gram per dm cube. Do you understand? Now from the relationship concentration of B in mole per dm cube, you know that one is equal to concentration of B in gram per dm cube all over molar mass of B. Okay, we know that molar mass of B is what? 40 gram per mole, okay, from the previous solution. Now, concentration of B in gram per dm cube, concentration of B in mole per dm cube will now be equal to, we know that concentration of B in gram per dm cube is 140 divided by the molar mass of B, which is 40. It gives us a 3.5 mole per dm cube. Please take note. The concentration that we are preparing for the Waec practical is very, 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 very small. Okay, not that as I'm getting 3.5 now, you will be if you now get in your own solution, you now get 0.00 something or 0.0 something or 0. something. Okay, you will be thinking you are wrong. You are correct, because the concentrations will always be very low. Okay, so to find concentration of A in mole per dm cube, we use the relationship CAVA all over CBVB is equal to NA over NB. Since we have gotten our CB, we can put CB in this formula, in this relationship, and get our CA. Like so, when you put that, you get your CA equal to what? 3.54 mole per dm cube. The same way, cross multiplying and doing whatever you do. Okay. Now, concentration of pure A in mole per dm cube. Okay, of course. the one you just got, like I told you in the calculation, the value you are getting is for pure A. The impurity is not involved in the reaction. So concentration of pure A in mole per dm cube equal to concentration of pure A in gram per dm cube all over molar mass of pure A. So if you cross multiply, you will get concentration of pure A in gram per dm cube will be equal to concentration of pure A in mole per dm cube times molar mass of pure A. Okay, so if you do that, 3.54 times 36.5. 36.5 is the molar mass of A. Okay, you get 129.56 gram per dm cube. Okay, which means out of that 174 gram per dm cube that we have of impure A, 129.56 gram were pure. Are you getting it? Do you understand? That is it. So percentage purity will now be concentration of pure A in gram per dm all over concentration of pure A in gram per dm cube times 100 over 1. Okay, concentration of pure A in gram per dm cube all over concentration of impure A in gram per dm cube times 100 over 1. Are you getting it? That is the formula. Okay, so that gives us 129.56, which is pure A, all over 174. Okay, times 100 over 1. That, if you calculate that, it gives you 74.46%. Sometimes they might ask you to calculate percentage impurity. Okay, once you calculate the percentage purity, you remove it from 100 to get percentage impurity. Do you understand? Yeah, thank you very much. I quite appreciate you for watching the video to this point in time. And if you find the video helpful, you can subscribe for more videos. My videos I'm bringing more videos on physics and chemistry, practical, and how you can manipulate values to get higher accurate results. Okay, so if you like the video, you should subscribe and share it with your friends. Okay, thank you very much.